Choosing the parts you want to use to build your computer can be very difficult if you do not know what you are looking for. This video aims to help you in that and will focus on certain parts and certain aspects of the computer that you should look for when choosing what parts to build. The first part I want to go over is the case. The case is important as it's going to house all of the components inside of it, and so you'll want to make sure each and every single component will be compatible. The first component to go over is the motherboard. The motherboard is going to go inside the case on standoffs. You'll want to make sure it can fit on those standoffs based on the form factor. Make sure the case form factor and the motherboard form factor match, or that they have alternate standoff points that you can use to mount the motherboard. The next part to go over is the CPU cooler. The CPU cooler may be too tall for the case, and you'll want to make sure that it can fit inside of it. Check the width of the case and the height of the CPU cooler to make sure it can fit. If you're going to use a water cooler, you'll need to make sure that the case can support that water cooler either at the front of the case or the top of the case. The next component to go over is the power supply. Much like a motherboard, a power supply also has a form factor. This can be SFX or ATX. You'll want to make sure your case can support that form factor power supply. The next component to go over is hard drives, or storage drives. You'll need to make sure that your case can support the specific amount of storage drives that you have. It may only support 3.5-inch drives or 2.5-inch drives, so you'll have to check on that. The last component to go over is the video card. The video card needs a specific amount of room inside the case, that way it can fit. To check this, you're going to need to check the length of the video card and check the maximum supported video card length that your case can support. Other than the compatibility of the case, you may want to look on the features. The first is aesthetics. You want to make sure the case is aesthetically pleasing to you through its color scheme and whether it has side panels that are tempered glass so you can see the components inside. The next thing to go over is cable management. The first thing to talk about with cable management is cutouts. The case will have cutouts that will allow you to route cables from one component to the next. You want to make sure there are a good amount of cutouts that will allow you to easily route cables through the case. The next thing to go over is tie-down points on the right side panel. You want to make sure there are a good amount of tie-down points. That way you can tie cables down to them and keep them close to this panel. The last thing to go over is the basement or power supply shroud. The basement or power supply shroud can hide cables under it, which can keep slack from appearing in the computer. The next thing to go over is airflow. You want to make sure that your case has good airflow and that it can sufficiently cool your components. You can check this with benchmarks, or you can just try and see it for yourself by looking at the included amount of fan. The last thing to go over is the I/O of the case. You want to make sure your case has a good I/O and that one that will help you be more convenient. That way you do not have to use the motherboard I/O. The next part I want to go over is the motherboard. The motherboard is what's going to connect all of the components inside of your computer so you can make sure they're compatible. The first thing to check is the CPU. The CPU and the motherboard will both have a socket type, and you need to make sure these match so you can use that CPU with that motherboard. The next thing to go over is memory. You make sure the double data rate type matches the double data rate type of your motherboard. Your memory and your motherboard must match, or they will not even be able to properly be inserted in the DIMM slots. Your motherboard also has a maximum amount of memory that it can support, so you need to make sure you use the same amount or less than that maximum amount. You also need to make sure that the frequency of your memory is supported on the motherboard. The next thing to go over are storage drives. You need to make sure that you have an M.2 slot on your motherboard if you plan to use an M.2 drive. Other than that, you need to make sure you have the right amount of SATA slots, that way you can use all the drives that you plan to use. The next thing to check is the power supply. The power supply needs the same connectors that your motherboard needs. That being, the power supply must have a 24-pin if your motherboard uses a 24-pin, and must have an 8-pin if your motherboard uses an 8-pin. There are also 4-pin and 20-pin that your power supply will need if your motherboard uses those connectors. The next thing to go over is the video card. The video card needs to be slotted in a PCI Express x16 slot. You'll want to make sure that your motherboard has one, that way you can use that video card. The final thing to go over is your case. The case I/O will need to have the I/O connectors on the motherboard. If the motherboard does not have that I/O connector, you will not be able to use that input on the case. You'll also want to make sure the motherboard has the features that you want. This comes in the form of a chipset and any onboard item. First, for the chipset is what determines the software features that your motherboard has, specifically in the BIOS or UEFI. This is important for overclockers, as you'll want to make sure that your motherboard will support overclocking. In terms of onboard items, if you need Bluetooth or Wi-Fi, you'll want to make sure that comes included on the motherboard, or if it doesn't, you'll want to make sure you'll have enough room on the PCI slots so that you can add an expansion card later. The next part I want to talk about is the CPU. The CPU is the part that's going to be running all of the applications on your computer. It will also be part of the multitasking that you do on the computer. You're going to see CPUs from two different main manufacturers. The first one is Intel, who tends to have better single-core performance compared to AMD, who tends to have better multi-core performance and more cores. It's arguable which one you should prefer, and instead you should look at the performance of the CPUs individually and compare them based on their price. The things to look for in a CPU is the core count, the threads per core, and the core clock. The core clock is an estimate of the performance your CPU can get, but instead you should be looking at benchmarks in the applications that you plan to run to see their real-world performance. Moving on to core count and threads per core, that is going to be the baseline for the multi-core performance and the multitasking that you can do on the CPU. If an application is able to use multiple cores, that will increase the performance, but it will also help with multitasking, as applications will be able to run on individual cores or individual threads. Speaking of the CPU, I want to talk about the CPU cooler. As you probably guessed, the CPU cooler's job is to keep the CPU cool. To measure the performance of the cooler, you should check the TDP, or thermal design power. Make sure that this is more than the CPU, so that way it can be adequately cooled. Some CPUs will also come with a stock cooler. This is basically the bare minimum that your CPU will need to stay cool, but I recommend getting an aftermarket one, especially if you plan to overclock. There are some compatibility checks you'll need to do with the CPU cooler. First, if you're going to use an air cooler, you need to make sure it does not impede on a RAM slot, or if it does impede on a RAM slot, that you will not use that RAM slot and it will not be needed. If you're going to use a water cooler, make sure your case can support it either at the top or the front of the case. That way you can mount it there. Memory is the next part I want to go over. Memory is important to the CPU as programs are going to be stored on it, and you'll want to make sure you have enough memory to keep those programs in storage and that it's fast enough to run those programs efficiently. The things to look out for in memory is the amount of memory and the speed of the memory, which will be a basis of frequency and latency. First is the amount of memory. You want to make sure you have enough memory to support the programs you're going to use. Typically, you'll use 8 to 16 gigabytes, but you can also get more if you need it. In terms of speed of the memory, you're going to have to look at the frequency and the latency of the memory to make sure that your memory will run at an adequate speed to be a big performance boost. This is especially important to Ryzen processors, as Ryzen relies on the speed of the memory. There are some compatibility checks you need to do with the memory. The first is with the motherboard. You'll need to make sure you have enough DIMM slots to support the amount of memory modules you're going to use. The next, you need to make sure your motherboard supports the amount of memory you're going to use, and you also need to make sure it will support the speed of the memory you're going to use. The last check to do with a motherboard is the DDR type. You need to make sure the DDR type of your RAM matches the DDR type of your motherboard so that it can be supported. Another thing that some people look over is the CPU cooler. The CPU cooler may impede on some memory slots, so you'll need to make sure that either it's freed up or you're not going to use that slot. The next part I want to talk about are storage drives. Storage drives is going to be the long-term memory of your computer, so you'll need to make sure you have enough capacity and that the speed is good enough to run programs more efficiently. The first type of drive I want to talk about is a hard drive. Hard drives offer the best price to gigabyte out of all the drives, but they're also slower than the rest of the drives. The speed of a hard drive can be measured in revolutions per minute RPM. The higher the RPM, the faster that drive is. I recommend hard drives for second-hand storage, things like programs that are not important to your OS, or just pictures and videos that you're planning to store. The next type of drive I'm going to go over is the SSD. SSDs come in 2.5-inch drives and they're a lot faster than hard drives, but because of that, they're also more expensive. I recommend you use an SSD as your boot drive, as that will help you to get the computer up and running quicker. You can also use the last type of drive, which I do not have, an M.2 drive. M.2 drives are small chips that will go onto your motherboard. The M.2 drive offers the fastest speeds with NVMe and the new PCI generation. If you really need these fast speeds, you can get an NVMe drive, but those are also more expensive than normal SSDs. The next part to go over is the power supply. The power supply is going to draw and send power to the components inside of your computer. You need to make sure the wattage of the power supply matches or exceeds the wattage your computer needs. To check the wattage your computer needs, you're going to have to estimate it. Add the recommended amount of wattage for your video card with the TDP of other parts to see what wattage your power supply needs. You can also use PCPartPicker.com and build out your PC inside the site, which will give you an estimated wattage. I recommend going 50 to 100 watts over that estimate, just to ensure your power supply can run that. A power supply can be non-modular, semi-modular, like this one here, or fully modular. The modularity of a power supply refers to whether or not cables can be attached or removed. A non-modular power supply means that no cables can be attached and no cables can be removed. A semi-modular means that the main cables will stay attached and cannot be detached, whereas you can attach and remove any extra cables that you need. A fully modular means that every single cable can be attached and reattached or detached as you need it. Modularity is important to cable management, as you can detach cables that you don't need or attach just the cables that you do need, or if you need to get extra cables later on, you can buy that cable and then attach it again to your power supply. The last thing to go over is reliability. You want to make sure you get a reliable power supply, as a non-reliable one may damage the components inside your case. You also want to make sure that your power supply will last for a long time. There's no real way to measure the reliability of a power supply, so the main factors to go on is that you get it from a trusted manufacturer, and then that manufacturer applies a good amount of warranty. I recommend 5 years to make sure that your power supply can run for at least that time. The next part I want to talk about is video cards. Video card is responsible for running 3D applications on your computer, and so it may not be important to all of you. However, it is extremely important to those of you that look to game on their computer. You'll see video cards from two main manufacturers with different board manufacturers in between them. The first one is NVIDIA. The next one is AMD. There's no real difference between the two in terms of mid and low end, but NVIDIA is the only manufacturer that is currently making high-end cards. They're also the only manufacturer currently that has a ray tracing card. That may be important to you, but people do not seem to like ray tracing, but that is up to you. The way to measure the performance of a video card is with the clock speed. The clock speed is a baseline for the video card performance, but you should be looking at benchmarks instead to see the real-world performance of that card. The next thing to look at is VRAM. VRAM is where textures will be stored inside the card, so you'll need to make sure you have enough VRAM for the games you're going to run. The last thing to look at is the I/O of the video card. The video card will have certain outputs that will need to go to your monitor. You want to make sure your monitor and the video card have the same input and output. That way you can use that monitor with the video card. If they do not have the same output, you'll either have to use an adapter or get a different video card. I hope this video helps you to better choose parts for your PC and to help better understand what each part individually does. If you need to build a computer after this, I'll also be posting a video about how to build one that will go step by step on each individual part. Thanks for watching.